All right, welcome everybody. This is part one of lesson 6.6. Today our content objective is going to be to model exponential growth and decay functions. And the learning objective will be to translate real-world situations into exponential functions. So we'll be doing both simultaneously. So let's look at our first example for exponential growth. It says a rare comic book is sold for $3,000 and its value increases by 7% each year after it is sold. Find the value of the comic book in 10 years. So if we look at this function, the function we want to build this and write this function. So v of t is going to equal, well, we know we're starting at a value of $3,000. So that's our a in our basic function format. As a reminder, it's f of x is always equal to a times b to the x power. And then that's going to be multiplied by the increase. It's going up by 7%. Now be careful, once again, don't put 7% in here. We got to remember it's going up by 7%, which means that we're multiplying it each and every time by 107%, or 1.07. So that's 107% as a decimal. And then that is going to be to the t power, which is time. So every year that it goes up. So now if I want to map out some values after year 1, and then we'll do year 4, 6, 8, 10, just kind of skip around a bit. After year 1, it'd be $3,210, and then it goes up to $3,932.40. And then in 6 years, it'd be at 4,502.20. After 8 years, it'd be at $5,154.60. And in 10 years, we'd be up past $5,901.50. Okay. So now we're going to just graph it really quickly. We can come down here. We know at year 0, it's right about here. It's at about 3,000. Okay, and this is just a quick approximation graph. If we go, these numbers are kind of hard to read, but we've got 1, 2, 3, 4, 5. So at year 4, we know that it's at about $3,900. Okay, and at year 6, it's at about $4,500, so somewhere in the middle. So we can easily see how our curve is behaving, in what direction it's going. So now we want to state the end behavior. So what is that behavior that it's doing? So we look here, as x approaches, again, that's what our arrow stands for, approaching. As x approaches negative infinity, so as x is going in the negative direction, what is y doing? Well, y is headed towards 0. Okay? As x approaches positive infinity, y is also approaching infinity. Okay? So now we want to talk about domain and range. What are the domains and what are the ranges of this graph? Okay, so domain. Domain, again, is always the x values. And so it is negative infinity is less than x, and x is less than positive infinity. Okay, because it can go in those directions. The range, then, is going to be as it approaches negative infinity, it's going to be 0. So y is greater than 0, but always less than infinity. Can't really go beyond infinity, so it's going to be less than infinity. Okay? All right, let's look at another example. Says Sarah sold a coin for $5, and the value increases by 3% each year after it is sold. Find the value of the coin in 2 years. State the domain and range of the exponential growth function for this problem and tell what the y-intercept represents. Okay, so let's talk about that. So our function, f of x, we know that it starts out at $5 and that it increases by 3% each year. So that's 1.03, right? 103%. That's what's being multiplied each and every year. And then we've got t years. So we could look at the number of years. We're going to do something a little different with this one. I'm actually going to go into negative years. So we can actually backtrack and see, like, what was this coin worth in previous years. So I'm going to do -2, -1, 0, 1, 2, 3. Okay. At 0, we know that it's going to be $5. That's its current value. At -1 years, though, it was worth $4.85 because that would be a 3% decrease. 2 years ago, was it $4 and about 71 cents? In the first year, it would go up to $5.15, then $5.30, and then $5.46. Okay. So again, we're going to graph this really quickly. We know the y-intercept is at 5, and then at about 2 years, it's going to be at about $5.30, somewhere around there. So we can definitely see, probably not drawing it very well here, how this is increasing. So once again, as x approaches negative infinity, y approaches 0. As x approaches infinity, y also approaches infinity. So the domain, negative infinity, is less than x, or in this case, x is greater than negative infinity, and x is less than positive infinity. And y is going to be greater than 0 and less than infinity. Okay? And then one thing you want to know is, what's the value of the coin in 2 years? 2 years, it's going to equal $5.30 will be the value of the coin, and the y-intercept, that represents the beginning of time for that coin. Sorry, there's the full problem. So make sure that you understand, a couple things. Make sure you understand how to take the information from the word problem and write the function, how to plot out some points for the function, how to roughly graph the function. It doesn't have to be perfect. And then what are the behaviors as x approaches negative infinity and positive infinity? What is y doing? And then be able to determine a domain and range from those values.